given a string, find the longest stretch of it where no character repeats more than twice, and return how long that stretch is. You are mid-interview. The prompt, find the longest substring where no character shows up more than twice. You write a triple nested loop, it passes the example, then the interviewer hands you a string with 10,000 characters and your solution just spins. Hey, I'm Kai, welcome to Fun with Learning Technology, where we turn interview panic into patterns that actually stick. Today, given a string, return the length of the longest substring where every character appears at most twice. And here's a little mystery. We only need one extra piece of memory beyond the string itself. Which one? Hold that thought. Think of a bouncer at a club who lets the same face in twice, but not a third time. That's this exact problem. Swap face for characters and you've got apps that rate limit repeat requests or log tools that drop a duplicate error after it's shown twice. Same shrink. The window idea, different costume. By the end of this video, you'll spot it in seconds. And you don't need a heap or dynamic programming. Just one dictionary and 2 pointers. Here's the string CEBA ABCACB. We want the longest stretch where no letter appears more than twice. Try BABCACC, looks fine. But add one more character and CC shows up a third time. Broken. The obvious move. On our string CEBABCACB, try every possible substring. That's index 0 to 1, 0 to 2, 0 to 3, all the way out. Then start over at index 1 and do it again. For each one, count every character inside it and check nothing passes 2. Watch how much rechecking that is. We're rescanning the same letters over and over. That's a loop inside a loop inside a loop. Checking every substring costs order n squared. Counting characters inside each one costs another order n. Multiply those together and you get order n cubed. Fine. On a tiny example, a flat-out timeout on a real interview size string. Instead of checking every substring from scratch, keep one window and just grow it, one character at a time from the right. Keep a running count of each character inside the window. Add the new character, bump its count by 1. The moment any count hits 3, the window is no longer valid. When a count hits 3, don't throw the window away. Slide the left edge forward, removing characters one by one until that character's count drops back to 2. Now the window is legal again, and we never recheck the middle. Here's the payback. Every character enters the window exactly once, from the right, and leaves it at most once from the left. That's our mystery variable from the start. One dictionary of counts riding along with the window. Walk right, bump a count, shrink left while any count is over 2, then check if this window beats your best so far. That's the elastic window, laid out end to end, and it just dropped us to big O of n. We start with an empty count dictionary, a left pointer at 0, and a best length of 0. Then we walk right across the string. Each step, we grab the current character and bump its count by 1, creating the entry if it's not there yet. If the character we just added pushed its count past 2, we shrink. We drop the count of whatever's sitting at the left edge and move left forward. And we keep doing that with the while loop until the offending count is back to 2. Then we score the window, its size is right minus left plus 1. Same logic, all in one place, grow with the for loop, shrink with the while loop, score with best. Nothing here we haven't already walked through. 2 small expressions do a lot of work. Count.get of C0 plus 1 means if we've never seen this character, treat it as 0, then add 1, so the first C becomes 1, and the second time we see it becomes 2. And right minus left plus 1 is just window size. If right is 7 and left is 2, that's 6 characters wide. Let's run it for real on bcbbbcba. Right walks forward, bumping counts as it goes. At index 3, B hits 3, so left jumps forward to 1. At index 4, B hits 3 again, so left jumps all the way to 3. By the time right reaches 7, our window is indices 4 through 7, BCBA, 2 B's, 1 C, 1 A, perfectly legal and 4 characters long. That matches the expected answer exactly. Clean, quick challenge before we move on. What does this function return for the string A? Pause the video, work it through with the window logic and drop your guess in the comments before I reveal it next. The answer is 2. No matter how many A's you have, only 2 of them can ever sit in the legal window. Now, the mistakes I actually see. First, shrinking with an if instead of a while. On a run of 4 identical characters, one shrink step isn't enough. You need to keep shrinking until the count is legal, which is exactly why it's a while loop. I made that exact mistake once and spent way too long staring at a aaaa wondering why it returned 3. Second, updating best before the string finishes, which can score a window that's still invalid. Since the string is only lowercase letters, you could swap the dictionary for a plain list of 26 counts, 1 slot per letter. It's the same big O of n time, but array indexing is a bit cheaper than dictionary lookups. Honestly, I think this is underrated. Most people reach for a dictionary out of habit, even when the alphabet is small and fixed. Time is big O of n. Left only ever moves forward, so total pointer movement across the whole run is at most n steps. Space is big O of 1, since the dictionary holds at most 26 letters no matter how long the string gets. Edge cases, a string where every character already appears twice or less just returns the full length, and a string of 1 repeated letter always caps out at 2. 1 pass, left and right pointers, a running count. No rescanning, no timeout on the 10,000 character string. That's the longest valid substring found in big O of n. Want to take this further? The exact same window and dictionary trick solves the general version of this problem. At most k occurrences, instead of a fixed 2, you just change one comparison. Python may look hard. Subscribing is the easy part. If something feels off or missing, or you want to see something new, tell me in the comments. Good quiz. We're tracking a count and a first seen index for each character. Why can't count alone tell us when to shrink the window? Pause and think it through. Take a second before I give it away. Count only tells you a char is over the limit, not where it first appeared. The index is what lets you jump the left pointer straight to the fix instead of rescanning. Round 2, your window just hit a third occurrence of some character, breaking the 2 occurrence rule. Where exactly does the left pointer jump to fix it? Guess before I answer. Remember, we don't restart from scratch here. Left jumps to one past that character's first occurrence. In a single move. No restarting the scan, that's the whole shrink it. Don't restart it idea.